In the last lesson, we saw that adding 1 to a pointer caused the pointer to point to the next integer in the array. This doesn't only work with integers. As long as C knows what the data type of an array is, it's able to calculate the appropriate number of bytes needed to move from one element to the next. Let's look at another example. In the Address Arithmetic 2 project, I've declared pointers to a variety of data types: int, float, double, long int, short int, and long int. And each of these pointers points to an array of the matching data type. I've assigned the arrays to the pointers and filled the arrays with some data. You can see that down here. And now down here I've done some simple pointer arithmetic by adding 1 to each pointer variable. And finally I print the results. Now let me run this. Right, so this is what I see. When I've added 1 to the pointer variables, that's had the effect of moving to the element at the next index of each array. If you look at the array address and the address of the first element, that is the result of adding 1 to the pointer variable, in each case the difference is the same as the size of the data type. 4 for an int, 4 for a float, 8 for a double, 8 for long int, 2 for short int, 4 for long int. You can pause the video or run the source code yourself if you need longer to look at the decimal versions of these addresses to see how they're incremented. I haven't had to calculate the offset myself. Nowhere in my code do I get the size of the data type and increment the address by that number of bytes. C's pointer arithmetic, when I add a value to a pointer variable, calculates the appropriate offset for me. In fact, on some platforms and with some C compilers, the sizes of data types may be different from the ones shown here. I ran this code just to test it out on my Mac, for instance, and when I did that, I noticed that a long int has a size of 8 bytes. You can see that shown here. Whereas on my Windows PC, the same long int data type has 4 bytes. Even so, I've been able to take the code that I wrote on my PC and recompile and run it on my Mac without making any changes at all. And it works correctly, because the Mac compiler automatically calculates an 8-byte offset for my array of long ints. So when I do my pointer arithmetic by adding 1 to the pointer variable, it moves 8 bytes in memory, rather than 4 bytes as on my PC. And that's how it references the next element of the array.